Hello everyone, my name is Clemens Preisinger, and today I would like to talk about the Karamba3D settings component, which is new in version 2.2.0. In the last episode of Karamba3D Tidbits, Matthew Tam showed you how to work with the Karamba ini file. The Karamba ini file basically defines the look and feel of Karamba, and you can set here, for example, also the physical units for geometric input or for the user interface. So manipulating this file would be one option to change the Karamba behavior. Another option is the Karamba settings component, which can be found here. In order to apply it correctly, one needs to know how Karamba works with these initial settings. When Karamba first starts, it reads the data from this Karamba ini file and stores it in a central database, which can be accessed from all Grasshopper definitions which are currently loaded. And this database persists until Rhino is closed. So, and this gives side effects which can be quite surprising. Let's see how this works and what I mean. So I placed here this component on the canvas. The output here under all settings is a replication of the Karamba ini file, as you can see here. So it would be possible to take this panel and stream its contents on the hard disk and use it as a new Karamba ini file. Let's use this new settings input to change, for example, the limit distance, which is used to snap together neighboring nodes. For this, I place here another panel, type in limit distance equal to, for example, 0.1. And this change immediately takes effect. And now if I add here an assemble component, I can see here that the default value changed. And if I open a new document and again place an assemble component on the canvas, you see that the change in the previous definition has an effect also on this definition here. In addition to this, changes which are done here in the settings component only affect components which execute afterwards, and also these changes here do not affect default values at the components. So if I change this value here back to 0.005, there's no change here at the input, but I would have to place here a new component, and now the change takes effect. So this is one thing one needs to be aware of. And also if I change now again this value back to 0.1, close here the definition and place here another component, the change still persists because the database to which the change was written also persists. So the recommended way of working with this settings component is to have a definition which only contains the settings component, do the changes here, load it, and then afterwards load the definitions for which the changes are intended. The type of problems that you can run into when the settings component is part of your definition will be shown now in this example here. It is part of the test examples of Karamba3D version 2.2011. It's called beam cantilever units. It's a cantilever beam where the input unit for the geometry has been set to centimeter instead of meter, which would be the default. So when you first load this definition, then Grasshopper executes it also. However, it's quite hard to place the settings component in such a way that it gets executed before all other components. For example, here we have the assemble component and 3 branches. And it's, for example, not guaranteed that the upper branch gets executed before all other branches. In fact, it's not the case. So the way how it is solved here in this example is that it is the settings component is made part of the execution path via this generic in, generic out input output, where some arbitrary data is fed into the input and comes out at the output, and in this way the settings component gets executed. For the second branch, an even more artificial solution needs to be used. Here the output is connected to a merge component which creates a list. From the list only the first item is taken, so this dummy input here is thrown away, serves here as input, and also in this way makes sure that this component is executed before this one. So you can see, as you can see, it's quite an effort to design the definition in such a way that the execution order is maintained in such a way that this settings component gets executed first. If I change now this, input here from centimeter to meter, I have of course also to change the length of the cantilever. But apart from this, everything basically works, as you can see, and also the result hasn't changed because the output units here stay the same irrespective of the input physical units. If I wouldn't have applied here this trick and instead would have used here this input directly, then if I change back to centimeter, I get here the scaled up cross section. I increase the length now from 5 to 500 centimeter. However, the load is wrong because this branch here gets executed before this one, so this component is still in the meter mode, whereas here we have centimeters. So in order to correct this, I have to hit the recompute button, and only now I get the correct result The same would apply if I loaded now this definition from hard disk. So the first run would be resulting in a wrong result, and only after a second recompute I would get the correct results. So that's the reason why it's quite dangerous to use this settings component as part of a definition. It's recommended, really strongly recommended, to place this settings component in a definition of its own. First, open this definition and then all the other definitions which shall take up these settings. Thank you for your attention. Goodbye.